Makar Sankranti. I will tell you, increase your own vibration in beautiful energy, because this time is very difficult time. We are all going to in difficult condition for COVID situation. But if you increase your vibration in beautifully, then world will be positive. At first, I will tell you, love yourself. And when you love yourself, when you believe yourself, then it will be more easier to receive love to other side. When you will give the positive vibration in the world, then world is also giving back to you. And every day, do some pray to God and tell to God, thank you for everything that I have in my life. And try to do forgive everyone, and at first forgive yourself, because we are all human beings. Every day try to speak God, thank you for every difficulties, because these difficulties makes us stronger person. So just keep increase your vibration in whole world. This is more necessary this time. Welcome back. Today I will see at first prime ideal. A prime ideal of a commutative ring R is a proper ideal of R such that A be any ring element of R if their product be member of ideal, then that implies either A belongs to this ideal or B belongs to this ideal I. Then this ideal I is called prime ideal. And here the notion prime means consider P be a prime number in integer. Then consider this ideal is generated by P. Okay? That means obviously this is multiple of Px where x belongs to integer. Then product of two element belongs to this ideal means P divide AB, and that implies either P divide A, that means A belongs to ideal generated by P, or P divides B. That means B or B belongs to ideal generated by P. That means PID who is generated by prime number is called prime ideal. And this is the actual idea of prime ideal. Recall, ideal of Z are of the form NZ, where n is any non-negative integer. I hope my all viewers have understood in Z which are prime ideal. In Z, NZ be ideal, and when n is a prime number, then these ideal are also prime ideal. And in Z, zero ideal also be prime ideal, because suppose two element AB belongs to Z such that their product belongs to this ideal, that means AB equal to 0, that implies either A belongs to this ideal 0 or B belongs to this ideal 0. Are you getting the concept of the ideal of Z? Well, now notice the ideal 6Z. 2 times 3 belongs to this ideal generated by 6, but neither 2 belongs to this ideal generated by 6 nor 3 belongs to this ideal generated by 6. So the ideal generated by 6Z is not a prime ideal, but if we consider 8z, then look, the ideal 0 is not a prime ideal because 2 times 4 belongs to this ideal. But neither 2 belongs to this ideal generated by 8 nor 4 belongs to this ideal generated by 8. In 8z, the ideal 0 is not a prime ideal. Now we'll see different type of prime ideal. Consider the polynomial ring Qx where the coefficient be rational number. That means those polynomial whose constant term be 0. Is this prime ideal? At first think. Obviously ideal generated by x means all polynomial in Qx whose constant term be 0. There are two polynomial fx and gx in Qx such that fx times gx belongs to this ideal generated by x. That means constant term of fx times gx is 0. That implies obviously either fx belongs to ideal generated by x or gx belongs to ideal generated by x. That means in Qx, ideal generated by x obviously be prime ideal. Similar to before, in Qx, the ideal generated by x minus 1, x ideal generated by x plus 1, ideal generated by x minus 2, ideal generated by x plus 2. Similarly, x minus 3, x plus 3, x minus half, 1 half, x plus 1 half, so on, be the prime ideal in Qx. All be similar to ideal generated by x. This ideal actually be multiple of x minus 1. Similarly, this ideal be multiple of x minus 2. Similarly, so try to oneself all be prime ideal in Qx. Not only Qx, if you consider K be any field, then in polynomial ring Kx, ideal generated by x, ideal generated by x minus 1, x minus 2, x plus 2, so on, be ideal in Kx where K be any field. Okay? And this type of example is very important for any competitive exam. Try to oneself. Just similar to before. Now I will see one interesting example. In Qx, consider the ideal generated by x square minus 1. Is it prime ideal? See, x square minus 1, we all of us know this is equal to x minus 1, x plus 1. That means we can write this ideal x square minus 1 is x minus 1 times x plus 1. But notice, neither x minus 1 belongs to the ideal generated by x square minus 1 nor x plus 1 belongs to this ideal generated by x square minus 1. So, in Qx, this ideal generated by x square minus 1 is not a prime ideal. Not only Qs, this is also true for all field Kx where K is any field. I hope now my all viewers have understood what is the prime ideal in polynomial ring. Actually, this example is very important for all competitive exams, CSIR, NET, GATE, TFR, so on. Now I will see one interesting thing. In Qx, ideal generated by x square plus 1, is it prime ideal in Qx? Just notice, in Qx, we cannot factor this polynomial. So, this is obviously B prime ideal. So this is rigorously B prime ideal in QX. But if we change the field, if we consider CX where C be complex number, then this ideal generated by x square plus 1, we can write it as easily product of two factor x plus I times x minus I. But the polynomial generated by x plus I nor belongs to x square plus 1. The polynomial x minus I also not belongs to the ideal generated by the polynomial x square plus 1. So, in CX, the ideal generated by x square plus 1 is not a prime ideal. That means, any ideal is prime or not only depend on the field. Not only QX. If you consider Rx, Zx, obviously this ideal be prime ideal. But when you will consider the field as a CX, then ideal generated by x square plus 1 is not a prime ideal. So, this example is very important for any competitive exam. Now I will see different type of example. Number of ideal. Consider F is field. Then this field exactly 2 ideal. Let's see the proof. If F is field and consider order of F greater than equal to 2, then obviously always I equal to, when trivial ideal, always be ideal of this field. Now consider I is an ideal and I not be trivial ideal. Then there exists obviously a non-zero element belongs to I. And this is belongs to I means obviously this is belongs to field. And we all of us know in every field, every element has multiplicative inverse. So 1 over A obviously belongs to this field. Then A times 1 over A obviously by the definition of ideal this is belongs to I. That imply 1 belongs to this ideal. We all of us know when 1 is contained in any ideal, then this ideal actually the whole group. Here group has considered as a field, so I equal to field. So in every field there exist only 2 ideal, one trivial ideal and other is whole field. Now I will see some example. As for example, if you consider Q real number, complex number, since both are field, so for Q rational number, there exists only 2 ideal, one trivial and other whole ring Q. Similarly for R, one trivial and other whole ring R. Similarly also the complex number, one trivial and other whole complex number. Okay? Well, now I will tell you one interesting question. I have seen in a field there exists always 2 ideal. But if any ring has exactly 2 ideal, then this ring is field? This is my question. And I will say it by an example. Consider a subring of Z4. Consider 2Z4 with respect to modulo 4. We all of us know this is contain only the element 0, 2. So, there exists obviously 2 ideal, one trivial and other whole ring 2Z4. But 2Z4 is not a field. Why? We all of us know every field is integral domain, but 2Z4 is not an integral domain because 2 belongs to 2Z4, but 2 times 2 equal to 4, which is congruent to 0 in modulo 4. That implies, obviously 2Z4 is not an integral domain. So the ring 2Z4 not be filled. Okay? Therefore, when a ring be filled, then obviously there exist two ideal, but it does not necessary to, if any ring contains two ideal, then this ring will be filled. My question, find the number of ideal in Q cross R. Consider R equal to Q cross R. Here Q and R both filled. Q contain two ideal, 0 and whole ring Q, and R contain two ideal, 0 and whole ring R. So the number of ideal in Q cross R are actually 4. One be trivial ideal when both are 0, that means 0 cross 0, and I2 when Q contains 0 and R contain whole ring R, then this would be singleton set 0 cross R, and I3b here R contain trivial ideal but Q contain whole ring Q, then I3 is considered as Q cross 0, and other ideal B whole ring Q cross R. That means there exist exactly 4 ideal in the ring Q cross R. Are you getting? Well. Now my question, how many ideal contain in the ring Z7 direct product Z11 direct product Q? Here the ring since Z7 is filled, this is contain only 2 ideal, 0 and Z7. Similarly Z11 contain 2 ideal, 0 and Z11. Similarly Q contains 0 and Q. Then I1 would be at first trivial ideal, I2 would be at first consider 2 0, that means this would be 0 cross 0 cross Q. I3 would be consider at first all 2 0, Z7 cross 0 cross 0, and other I4 would be 0 cross Z11 cross 0. These 3 ideal contain 2 0. Now consider 1 0. I5 would be 0 cross Z11 cross Q, and I6 would be Z11 cross 0 cross Q, and I7 would be Q cross Z7 cross singleton set 0, and I8 would be whole ring, means Z7 cross Z11 cross Q. That means this ring contains only 8 ideals. Are you getting whole idea? Well. And the number of ideal of Zn is as like a subgroup. It is defined as tau n. As for example, if we consider the ring Z12, then tau 12 equal to 2 square times 3. This would be 2 plus 1, 1 plus 1. That means this 3 times 2, 6. That means there exists 6 ideal in the ring Z12. Let's see which ideal are. 6 distinct ideal of Z12 are Z12, ideal generated by 2, ideal generated by 3, ideal generated by 4, ideal generated by 6, and ideal generated by 0. In Z12, whole ring Z12 is equal to actually ideal generated by 1, and this is also equal to ideal generated by 5 and also equal to ideal generated by 7, and this is also equal to ideal generated by 11. And here also ideal generated by 4 is equal to ideal generated by 8. So these are distinct ideal in Z12. Okay, are you getting? Well, today I will stop here, but I will highly recommend you please see this video with pay attention. Stay safe and stay positive always. Don't forget to subscribe my channel for more videos. Thank you so much.